All right, today we're going to shift gears from making the quantitative and categorical displays, and we're going to talk about how to describe quantitative data. So we're going to talk about shape, center, and spread today. Shape, we'll kind of get the whole discussion going today. Center is going to be one that we're going to drag out over the next couple of lessons, and then spread will also be one we kind of drag out because there's lots that go into determining the center, determining what spread, what to calculate, how to interpret, things like that. So as far as examining a distribution, the key thing is we always look for the overall pattern. So we look for where the majority of the data lies. We look for patterns within the data, and then we try to notice any like deviations, anything that falls outside of the general pattern, which we would deem as outliers. So that could be a value that's way higher, way lower than some of the others. There could be multiple outliers within a given set, but basically we're looking at, okay, well, what's the overall pattern? And then are there any unusual features, anything unusual about any of the data points within our set? Histograms, and for that matter, dot plots and stem plots can be described using shape, center, and spread. So these three things right here, anytime they ask you to describe a distribution, you have to mention these three things. So what shape does it take on? What is the measure of the center? What's the measure of spread? And how do we interpret some of those ideas? So we're always looking for like major peaks in the bars. We're ignoring small ups and downs, focusing on big picture. So we want overall what's looking like, or what's the pattern look like, versus I have some slight up and downs throughout that could be irrelevant to the overall scheme of things. So when we look at outliers, those are classes or individuals that fall outside of the overall pattern. So for instance, if we look at this histogram here, this histogram looks at the percent of state residents age 65 and over. So they went to the 50 states, they looked at what percent of state residents were 65 and over, and so they got this histogram from the results. Well, what they noticed was there was one state that was in the 5 to 6% range, there was one state in the 18 to 19% range, but then the majority of our data was housed right here between 8 to 16%. And so if we're looking at this, this would lead us to believe that 5 to 6%, 18 to 19%, those two states would be possible outliers. And I say possible because we're going to have a definitive way of determining outliers in one of our future discussions. But they don't fit the regular pattern. And so if we examine those outliers, a lot of times when we see outliers, there's something that we want to take a look at. It could have been just a mistake in the calculations or measurements, or it could be something that actually provides some useful information. Like in this case, that low value corresponds to Alaska, which would make sense. Older people wouldn't want to be living in that harsh environment versus the 18 to 19%, which lives in Florida, which is a more tropical climate, a lot better for a lot of older age ailments. And so we can clearly see why those particular states would be where they are. And then, like we said, the other 48 states kind of fall within the normal pattern. So that's kind of one of the things we look for is, okay, are there anything that fall outside the regular pattern? What might be the cause of that? And we kind of investigate further. As far as shape is concerned, so with shape, we're going to kind of use this graph here and kind of show you what they look like. Symmetric, skewed right, and skewed left are the three different types of, or the three main types of descriptions for our different distributions. Now, symmetric would be one where basically the left and the right side are kind of mirror images of each other. So this blue line that I've drawn here, we see that the left and right side of the distribution are fairly similar. So left side, right side, mirror images or close to. So when we talk about symmetric distributions, we're saying that the peak is in the middle and then both sides on either side are about equal in terms of decline from there. For the skewed right, so in skewed right, what's going to happen is we're actually going to hit our peak early and then we're going to tail off towards the end of the distribution. So it's going to hit that peak right away, and then the right side is going to drag on and on and on. And so we say that that's skewed right because that's the direction the tail takes on in that situation. So when we skew to the right, early peak, right tail goes on for a little while. Skewed left is what you actually see in the graph here, where now we're hitting our peak really late, and we see that the tail kind of drags out to the left side of the graph. And so basically what we're looking at with that skewness is, do we have one tail that sticks out much further than the other? And a lot of times when we talk about skew, you want to kind of keep in mind that yes, one side might be a little longer than the other, but unless it's a dramatic fall off one direction or the other, we typically stick to the symmetric, or we might use the word roughly symmetric designation. So like if we go back to this histogram from over here, as we look at this, we notice that in this histogram, the peak is pretty close to right in the center. Now, while the left and the right sides aren't exactly identical, if we were kind of to fit a curve to this, we notice that for the most part, they do kind of fall off at the same rate either way. So it's about equal on both sides. And so in this case, we would probably say something like roughly symmetric, because there's not that tail obviously falling one direction or the other. And then just like with anything else, we would want to comment on those outliers that we discussed previously. But that's kind of what we're dealing with shape. So we're looking for where that peak is, we're looking for where the tail goes, and if there isn't any, then we're just going to say it's fairly symmetric. The only other one that you might see, and it shows up a couple of times from time to time, is what we call a uniform distribution, which means from start to finish, we're almost the same height all the way across. So it's almost like it just forms a giant box in that case. So that's also called uniform, which is another shape, but it's not one you're going to see very often. So typically when they ask you to describe, you're going to say symmetric, skewed right, or skewed left, based on where that center is and where the tails go. As far as the center of the distribution, we said this one's going to be a topic of discussion for a couple of lessons. There's two different types of center. There's mean and median. We're going to talk about the median today. And so when we talk about center, we're saying like in a histogram where we're unimodal symmetric, meaning that we have one hill and it's right in the middle. The center is pretty easy to find because it's right in the middle of the hill. On the other hand, if it's a skewed distribution, so skewed left, skewed right, sometimes that center can be a little bit trickier to find. But as far as what we're going to talk about for today, the median is the midpoint of our distribution. So it's the exact middle point. It's 50% of the observations are above it, 50% of the observations are below it. And so it's the midpoint of our overall distribution. So if I'm looking at a distribution like we see here, this histogram, you can see that they split right at this point here from blue to yellow. And so they're saying that the actual median would be a magnitude of 7.0. And so when you're looking at these, when there's no clear-cut data to work with, you're kind of giving your best estimate as to where that center is going to lie. And so typically, like on a homework or a quiz or test, if I'm asking you to find the center and I don't give you the data, I just give you a graph, I'm going to have a little bit of a range of values where you could pick where you think that center is. So you're just trying to figure out where does that midpoint seem to fall within that set of data. So I want 50% left, 50% to the right. And so it's going to be close to where the peak is, but it's going to kind of go in one direction or the other, depending on which skew direction it goes. So when we talk median, the other thing to note here, the median has the same units as the data. So if I'm measuring things in kilograms, my median is in kilograms, and so on. So anytime I report a median, I have to put the units that also go with the data. As far as calculating median, we're going to talk about by hand here for a second, and then we'll do in the calculator a little bit later. But as we calculate median, we're going to take all of our observations and we're going to arrange them. The easiest way to do it is smallest to largest, so do it in ascending order. If the number of observations is odd, then the very middle number is the median. If you have an even number of observations, the mean of the two numbers in the middle will be your median. And so I'll give you an example of each of those here. So in this first example, this is our original data set. So the first thing they want to do is we want to take that and reorganize it in ascending order. So smallest value here, largest value here. And then what we do is we kind of start in the middle, or start on the outsides, and we work our way in to the middle. And so we would work our way in from both sides. There's my midpoint, so that's my median of 39. If I take a similar data set, so like right here, and I rearrange it, small value here, large value here, when I follow to the middle, I actually end up hitting two numbers in the middle. So what I'm going to do is I'm going to take those two numbers and I'm going to calculate the average of those two. So between 39 and 42, my average would be 40.5. That would be the median for my data set. And so by hand, that's basically what you're doing. Organize in ascending order, start on the outsides, work to the middle, take the very middle value if it's there, or average the two middle values if you run into that. As far as spread, gives a description of how the data varies around the center. Spread is going to actually have three different types of calculations, and so this is another one where we're going to talk about this over the course of a couple different lessons. But for right now, what we're talking about is range. And so range is one we can typically find or at least estimate whether we get the information or the data or whether we're given a graph. And so the range is a difference between the maximum and the minimum values. So range is not what we typically think of in terms of like we're going from 4 to 10 or things like that. The range is an actual number, one single value that determines the difference of the maximum and minimum. Now the range does have a disadvantage in that a single extreme value can make it very large. So if I have an outlier in one or both directions, that's going to make a much larger range calculation than would happen without them. And so if we look at the example from before, the state residents 65 and over, what we look at here is they actually tell us the data. So the maximum was 18.7%, the minimum was 5.2%. So my range is 13.5%. So it says our data ranges about 13.5% from minimum to maximum. And so whenever you're giving the range will always be in the same units as the data, and it's always one single number from the difference of the minimum and maximum. The other thing, though, is that in this case, when they told us the actual values, we could calculate the exact range. But if we didn't know these things, so say they had not given us those, the best I can do here is I know that 19% would have to be the absolute max, 5% would be the absolute min, so I could take 19 minus 5 and at least estimate my range with 14%. And so that's also an option. If you don't have the data at hand, just take that absolute max, absolute min, subtract them, and at least give an estimate value. So we got shape, talking about symmetric or skewed in one direction or the other. With the center right now, we're talking median. So whether we need to calculate it or whether we need to identify it within a given graph, we just try to find that midpoint. And then for range, again, it's the difference between the maximum and the minimum. So it's a single value with the same units as the actual data. When we compare distributions, a lot of times we're more interested in how one group of individuals compares to another as opposed to just how does this one individual look. And so anytime we're comparing distributions, we always want to comment on the shape, the center, and the spread. Anytime I'm talking distributions, those three things need to probably be in the conversation. And then also possible outliers whenever possible. So if we look at another example here, comparing two distributions. So as we're looking at this, these are the common household sizes for two different countries. So we've got South Africa up top here, and we've got the UK down here. Now, from the sample that they took, we look at the household sizes for each sample, and if we were asked to compare these particular distributions, well, as far as shape is concerned, UK is fairly symmetric, okay? So there's not really a tail one direction or another, so we would say the UK is roughly symmetric, whereas the South Africa distribution tails off to the right side, so it's going to be skewed right. So I've got symmetric for UK, skewed right for South Africa. If we talk about centers, the center of the UK distribution would probably be right about 4. So the average household size would be about 4. Whereas in the South African distribution, it's probably closer to about 6. So the average household size is a little bit different between the two countries. And then as far as spread, we see that the UK households are all within this range of values here. If we wanted to calculate the actual range, we would take 6% or 6 people minus the 2 people, and so we'd have a range of 4. But if we went to South Africa, it has a much larger range. It goes all the way from 3 people in a household all the way up to 26 up here. The other thing we would want to comment on is at least here we have an outlier in this particular data 15 is a possible outlier as well. And so those are things we would want to comment on as far as what these look like. So when we compare, okay, how do the two shapes compare to one another? How do the two centers compare? And then how do the two spreads? And then anytime any of them have any sort of outliers, we want to make sure we comment on those as well. So with that, you should be able to complete the homework for today. As you're working through that, if you have any questions or anything, make sure you ask in class or come in outside of class and get some help. Look online at the answer keys and try to get some help to complete this one.